Well, good evening, everyone. Welcome to the March meeting of the Ottawa Centre of the RASC. Thanks for all coming. My name is Mike Mogadam. I'm standing in for Bill Wagstaff, who's away this month. So, slide, please. So for those who know me, you know that I have an outreach interest, and you're probably a little apprehensive right now, thinking that what is he going to do? He's going to stack the deck with a slide deck with nothing but outreach. Well, I want you to know I'm a balanced person. I believe in representation, and I was really surprised to see, as I know you are too, that so many people stepped forward and are offering outreach slides. So go ahead and enjoy tonight, and we'll go. Just joking. The observations are there. All right, so yeah, balanced person. Somebody told me recently, sure, you're a balanced person. You got a chip on both shoulders. Okay, you're probably not going to want to have me back after tonight. We'll see. After 90 minutes, an hour and 2 hours, you're going to be throwing tomatoes at me or whatever. Okay, so here's the plan for tonight. Ottawa Skies, Gary Boyle is going to be sharing a overview of what we can expect in the month of March. Sylvie's giving a 10-minute overview, as she always does, a 10-minute astronomy news, as she always does. John Thompson's going to be talking about his visit to Easter Island, where there was a total solar eclipse in July. Some real cool videos he's going to share with us. Pierre, our local meteor enthusiast, has got some photos from a recent journey, which will inspire you all. After that, we'll have a short break as usual, followed by observations and the highlight of the night, public outreach. And Chris is going to share. He had a talk about one or two meetings ago about some astronomy applications. He's going to give part 2 of that. Okay. Okay, one of the things I always like to ask is there anyone here for the first time tonight? Someone maybe just raise a hand. Any new people? Well, thank you for coming. You've been here before. I didn't see all the hands. It's pretty dark out there. If this is the first time you're here tonight, thanks for coming. I hope we make it. I hope you find it interesting and also fun. These meetings are open to everyone. There are no charge for the meetings. You can come as many times as you want. But I thought I would. I don't want you to think that I'm pushing membership, but I'd like to at least tell you what membership in the RASC offers. So I won't go through each of these items here, but I wanted to sort of point out some things that you might not be aware of. So we do have a telescope library, which means that as a member, if you don't have a telescope and you're interested in buying one day, you can try before you buy. So you can sign out a telescope much the same way you sign out a library book. I think there's a small fee for $10 or something like that. We do have a library here as well, a book library where you can sign out astronomy books as well. It's a wonderful thing. In addition to all that, there is a Fred Lossing Observatory where members can use this. It's in the Elmont area, and there's lots of activities. So in being a part of our group brings collaboration, knowledge sharing, and all that stuff. So if anybody wants to talk more about it, and nab me at the break, and I'm happy to talk about it. Next slide. Okay, one of the things that we talk about at the is this too loud for anyone, or okay? What we talk about usually at the end of the presentation, which I thought would be a good idea to talk about at the beginning, is that we're always looking for subjects. Okay, some people to come forward and speak in future meetings. So one subject of interest to me is, or at least lately, is archaeoastronomy. Okay, which is the one item there, and I'm sort of putting out a call for people who have an interest in archaeoastronomy. And maybe I should take a step back and explain what that is for those who don't know. It's really the study of how our predecessors or earlier cultures, how they understood or read the night sky and the patterns and the regular patterns in the night sky, and determine the time of the day and the dates and so forth. There's a lot there, and I'm not just talking about Stonehenge. I'm talking about what other cultures have done. So if anyone has an interest in this, okay, and want to share some of their experience, either some journeys that they've taken or whatever, I think this would be a terrific sort of multi-meeting subject. All right, next slide. Okay, one thing we always like to do is share about some of the the exposure that some of our local members have received. This issue of Sky News, I don't know if everyone noticed, right at the on the cover, there was the local amateur astronomer's image of Orion Nebula. That was taken courtesy of our local member, Sanjeev Siva-Rusa. And Sanjeev, well done. Are you here? Next slide. I think Sanjeev, if he's not here, he's here later on because he's going to talk a little more. Also, in the very same issue of Sky News, you probably can't see it, it's a little dark. Open up to looks like almost the middle of it is Pierre, a wonderful picture from Pierre Martin on a journey that he took recently, and he's going to be talking about that, a journey down south where he took a lot of images of the Geminids. Okay, so I won't steal Pierre's thunder, but awesome picture, Pierre. Just amazing, truly amazing. Okay, another thing that has come up recently here is that in the included with the Ottawa Citizen, there is a little edition called The Wrap. And it's a series of articles on astronomy written by Brian McCullough. And there's one that's actually was just included today in with today's Ottawa Citizen, a full-page article here. And well done, Brian. This is a terrific exposure for our center there, and just really promoting amateur astronomy in general in our area. Excellent work. Okay. All right, I think first up is Gary Boyle, who's going to give a view of the night sky as emerge.
Thank you, Mike, and good evening, everybody. Well, first, the bad news. In February, as always, as Tim Cole would always avail, we've had clouds. Well, actually, in my observations, I do record weather conditions. So even an observation, if it's raining or even cloudy, that's still an observation, so I'd still write it down. So as we can see, we had a total of 4 good nights, all the way down to half the month was either cloudy, rain, or snow. Not very good. And what's the prediction for March? Who knows? Chris with his wizardry just showed me that. Nice lot. Next slide. Coming up this weekend, in fact, today is New Moon. It's lunation number 1091. So New Moon is this weekend. A great weekend for the Messier Marathon, but just not for here. Freezing rain, snow, rain tomorrow. Just a terrible weekend. But for any of you that do not know what the Messier Marathon is, in March, it's the one time of year when you can pick off or observe all 110 Messiers on the famous list without interference from the sun. Of course, you do need the new moon, so you don't have any moon glow. But just in the area where the sun is this time of year, no Messiers are around that area. So theoretically, you can do 110. And I've gone to about 85 on one marathon. I haven't tried it since. Has anyone ever tried a Messier Marathon? And what's the highest if anybody went? 6? 6 Messiers? Or 6 marathons? I do 20 with my eyes closed. Okay, so anyway, we'll have to try it again next year. But really, it's an all-nighter. And do it by eye. Really, you shouldn't be using computer-automated telescopes or robotic telescopes. That kind of defeats the purpose. Okay, next slide, please. Well, a little hosh-posh showing all the constellations over here. We have Orion, which is setting in the western sky right now. Gemini with the twins, which I wrote this month in my monthly article on the e-news. And we really have Leo coming up here. Leo is known as a springtime constellation, mostly for the many, many galaxies, both in Leo and in Virgo. In fact, just off of Denebola right down to in here, you have literally hundreds and hundreds of galaxies. There's about a good 10 or 15 Messiers just in this little area. And of course, we have Saturn over here too. So you can see that the sky is connected, various constellations, different sizes. You probably heard last month or so that the horoscopes change. Who follows their horoscope every day? And believe me, I'm not putting up my hand. I just want to show my hands. Those that want to actually admit that they follow their horoscope every day. Well, it's great to see that they finally moved the dates into actual times nowadays. I mean, I'm a Capricorn. January 5th is my birthday, but I'm really a Sagittarius now. But really, the sun moved from Capricorn into Sagittarius about 500 years ago. And I just couldn't imagine why they haven't done this before.
Well, the good news is that it's still just as accurate as it ever was.
Yes, it is accurate. Very good. Good observation. Good observation. But now with the new horoscopes, the days that you actually see, those are the days that the sun actually traverses in the constellation. And even with this shot over here, you'll see that here is the ecliptic. And we have all different sizes, different areas. So it's not that 29 or 30 days that the old horoscope used to have. The ecliptic, of course, you had 12 houses in the old zodiac. Now they said the 13th mysterious constellation. Well, that's Ophiuchus. It's always been there. The sun's always traveled through Ophiuchus. So in my courses, I've always told my students I could never believe why just the dates were wrong and just 12 houses. So really, the good thing is they actually brought it into the true sky what it is nowadays, but still, just use it for entertainment. Do not plan your day around it. It's pure entertainment purposes. Okay, next slide, please. If we can just go back one slide to previous. Just over here, just about over here, here we have Leo the Lion, which is a nice backward question mark in the sky. And this is in the early days of antiquity, the earlier farmers that lived around along the Nile in Egypt, when they saw Sirius rising early in the morning sky in August, they knew the change of seasons would come. And they would harvest their crops or they'd lose it to the floodwaters of the Nile. Well, now the same thing with Leo, the lion, seeing that rise in the early evening. Now they knew that pretty well ballpark that the seasons were changing, the weather was getting warmer. Now it was time to actually seed the crops in their fields. So using the sky as a celestial calendar was pretty ingenious. But one thing that we love Leo for, like I said, are galaxies. And with the backward question mark for the mane, and there's a nice triangle here for the tail, or the hindquarters, just about over here, we have a nice threesome. It's called the Leo trio, M65, 66, and NGC 3628. 3 galaxies which you can see in a very low power telescope, just about 60, 70 power. It's great to see multiple galaxies in one field of view. All 3, 65, 66, and 3628 are about 35 million light years from Earth. And 65 is about 70,000 light years wide, and 66 is about 90,000 light years wide. I'm not sure what the actual width of this guy is.
I've always wondered, why would Messier not have identified 3628?
I have no idea. Some of the Messier objects, it's like, how do you ever miss? I have no idea. No idea. I mean, it was right there. Right there.
It's fainter visually.
Maybe he had a tree in the way, or I have no idea. It's
much fainter and it's got a low surface brightness compared to the other two.
Yeah, the same with 95, 96, and 105. I think 105 is just as faint too. Yeah, it was or it could have been that night. No idea.
Well, his telescopes would have also had very small fields of view.
Yes.
The
Yeah.
old eyepiece designs were not one field.
Yeah. So probably just missed it totally. But I'm glad we have it now. Dane, next slide, please. Well, coming up on March 11th is the famous Lunar X, and Lunar X is a beautiful. It's not an X on the moon as such, but really it's the illumination of the sun at a perfect time when the sun is just starting to rise over those craters. And the crater is actually called Werner, over here in the square, just over here, and X will mark the spot. So on March 11th at 11 p.m. Eastern Time, check it out if it's clear and see the X. Brian, about how long does the X last for? About half a day, or?
Yeah, it'll last a few hours.
A few hours, yeah. You don't get the illusion for too long. And usually the moon's is during the day when this occurs, so it's not every first quarter. I mean, the moon's got to be 41.9% lit. Of course, libration, it's got to be a little different. So it's not every month you will see the X. Sometimes during the day, sometimes not. And again, if it's clear or not. So, and well, let's call that as a lunar challenge. I'm just putting out there, if you want to look for lunar X, here it is about 3/4 of the way down the actual terminator. Not our Schwarzenegger, but the terminator between the lit and the unlit side of the moon. Next slide, please. Don't forget to move your clocks ahead 1 hour. And don't forget, too, for universal time, then subtract 4 hours from any UT listing in the Observer's Handbook or any other source that you might use. Now it's 5 hours, but as you spring ahead, it's at 1 hour less. So 4 hours subtract. Okay? And next slide. Next is on March the 13th, starting at 4:50 p.m. The moon is actually going to occult Mu Geminorum. Here's the constellation of Gemini. And just a foot just below Castor, which is up here. Down here is a nice, pretty bright star. No difficulty at all. A decent time, even though the sun is up, you should still see it in telescopes. And it should last for about an hour. The star should disappear for about an hour. Okay, next slide. Zodiacal lights, beautiful shot taken by Ralph Meyer. A few people have even seen it here visually. Joe Bonner, one of my students, my great students from Algonquin, he noticed it visually. And where were you, Joe? In Barrhaven when you saw it? And he had a friend that lived in Elmont to confirm, and so it was. So the zodiacal lights, and with Jupiter in the middle in this shot, great shot by Ralph too. Really, zodiacal lights are seen in March in the western sky and around October or September in the eastern sky before sunrise. And what it is really is the interstellar dust of our solar system that's on just a nice sharp angle. Imagine if you have, who dusts every day? Nobody dusts their furniture every day. Well, after a week or so, you're going to notice dust on any kind of table. But if you look along the surface, you're going to see a lot more dust. Well, the same thing over here too, but the interstellar dust in the actual, in our solar system that you're looking. Again, a good time now because the moon is not going to hamper the sky at all. On the 19th is the full moon, or the worm moon. Really, the Farmer's Almanac, they do have a name for each moon, just like we know the harvest moon, the hunter's moon. It's only 2 months, but they actually have a moon name for each month of the year. And this one coming up is called the wolf moon. It'll be the largest moon of the year, exactly 356,000 kilometers from Earth at 2:05 in the afternoon for people that follow that kind of stuff. You will not turn to werewolves. Next slide. And the great spring equinox. I pretty well laugh when people say, ooh, it looks like an early spring this year. No, spring is only going to be on March 20th at exactly 7:21 p.m. We'll get an early thaw, but not an early spring. But it'd be great to move from this, I see this, to get to this. Bugs and humidity and allergies and all the good stuff.
It's autumn.
It's autumn. Yeah, well, it was a short summer. One of the best slides I had. Good observation. Yeah, this was taken in October near Mont Tremblant.
You can't have early spring, but you can have a short summer.
Exactly. And I was just reading today through NASA Science, they had a report that came out yesterday, in fact, why the sunspots disappeared for about a year and a half. It's to do with the internal currents, just like we have in oceans. It's called the Great Conveyor Belt, and it's about 300,000 kilometers below the surface of the sun. And really, just the convection belt kind of slowed down, so it didn't produce the sunspots as it should. So, of course, because of what technology nowadays, we can actually learn this stuff. Okay, next slide. Okay, just quickly, here's Saturn. Beautiful object. Saturn's rising about 8 p.m. It's in the eastern sky, very easy to see. So if we have Saturn over here, we have a Spica down here. So it's the two brightest stars. It'll be the one on top. And people with large enough telescopes can see all 7 moons around Saturn. The good thing about Saturn, too, is now the rings are tilting a little more. They're about 10 degrees. Getting a little better. Okay, next slide. And really just where the planets will be lying throughout the month. People that looking at Venus is pretty well hitting the rooftops at 5 o'clock in the morning, very, very low in the eastern sky. Mars not visible, Venus or Jupiter, we're eventually saying goodbye to Jupiter. It's a pretty good year, especially with the missing belt, which is coming back now. Uranus and Neptune, as you can see, is just not seen conjunction or moving across in the sky. And lastly, just the lunar dates with new moon, first, full, and last quarter. And that's a wrap. Thank you.
Thanks, Gary. Appreciate it.
If I could just make a comment, you were talking about the horoscopes and that, and you're referring to the horoscope of Capricorn. Of course, the constellation name is Capricornus.
Okay, Gary actually mentioned it really briefly here. I mean, for those of you who don't know, Gary actually writes a monthly article that's posted on the national website, Northern Skies it's called, and if you're just go to the RAC national website, and you can follow it's very easy to follow and find and so forth. But it's a nice piece of work too.
There's actually a link on the Ottawa Centre website. So it's just about e-news.
Terrific. Hey, is there a link from the new Facebook page as well?
No. No.
Okay, we should probably add. Okay, great. Next slide. All right, Sylvie Letourneau, you're up for the 10-minute astronomy news update.
Thanks, Mike. Oh, excellent. Sorry, I'm short. Okay, let's kickstart this thing. Wow, I pressed the right button. This is a good night. Okay, so for this month, I decided to talk about the Spitzer Space Telescope, the infrared space observatory that was launched quite a while ago, but is still doing some good work for us. That is a NASA, JPL, and Caltech project for a little over 800 million US dollar. And a couple months ago, Al Scott talked about buckyballs that were found by Spitzer. Buckyballs. And why is there so much echo? Boom, boom. No?
Stand back and don't talk directly.
No, but I mean, I'm just breathing here.
Yeah, that's enough.
Stand back.
Stand back.
Get away from the barrier. Okay, let's try this. Okay, if you don't hear me, well, that's okay. You can have a little nap. After seeing that talk from Al, I got a little curious, and at the same time, we got an Apple TV, which has wonderful videos about Spitzer called Hidden Universe. So I did a little bit of research, and well, it's been launched since 2003, and oh my goodness.
Push it back a bit.
Well,
Don't talk directly at it, but at a bit of an angle.
like this?
Because when you talk
So
to
my
it, you
God,
get the pops of
That's
your
your good
breath.
side. That's perfect.
This is, okay, will take 10 minutes just for me to adjust to this thing. I'll just step back and take it easy. So the mission was, they were planning for 2.5 years and hoping for really an expected 5 years of work out of this telescope. And that was due to the liquid helium supply that was on it. Now, that liquid helium only ran out in 2009, so therefore they got a good 6 years out of its all of its instruments, which were 3 instruments. There was the infrared camera, there was an infrared spectrograph, and there was also a multiband imaging photometer. Now, only the IR camera is still working, and it's still operational at the 2 lower wavelength that we have there. But that's still very good. Spitzer is going on with its warm mission, and it's still doing some great work. Now, what I want to point out is the old idea of sending that infrared telescope into space was that if you have it ground-based, is you will have infrared radiation that will interfere with your measurements or your pictures from the telescope itself, from the atmosphere, and also most of the atmosphere is opaque to some of those infrared. Therefore, having it in the up there was advantageous, and using the infrared was good as well to see the stellar nurseries, big swirling dusty parts of galaxies and disk of planet forming and also organic material. So as Spitzer has had a long life, there's a lot of data, a lot of pictures, a lot of discoveries. So what I did is I picked two of the past one and one of the recent one from this last month. So this is a while back where the Helix Nebula was imaged with Spitzer. And you're probably familiar with the one to the right here, which is a visual picture of the Helix Nebula, NJC 7293, right, Paul? I'm sure you'd correct me if I don't say it properly. 7293. Thank you. So this is a planetary nebula in the constellation of Aquarius, and it's only about 700 light years away. It's pretty in the visible light, but when you switch to the left and you see it into the infrared, you start to see a lot more details. Unfortunately, from your spot, you can't see it, but believe me, if you were to have this picture in front on your computer, in the middle, which I can't point quite just good, is actually a white dot, which is that white dwarf. The first red circle, which would be just about there, is all warm up at a dead star, and it's a dusty disk. The rest of the red is the final layers of the gas that have blown out from this dying star, and then you get other gas layers in blue and green all around, forming that evil eye, or so I like to call it. Now, the shorter wavelengths are blue, and you go to green, and the longer wavelengths are red. What was interesting in there is in the visible, you can't really see unless you do a big close-up like Hubble has done, but there are those interesting pillars, or they call them nuts, clumsy structure that are actually twice the size of I'm gonna turn you banana. Twice the size of our solar system. So those little things are not that little, but they are very interesting. Before Hubble could look at them, you could see them through this space telescope, because you could, as you zoom in, you can see on this picture how lots of stuff are radiating from the center. Now the surprise here was that that dusty disk found around the dead star proved that there would have been comets surviving, which is not, or that Helix will be one of the few dead stars with a comet survivors. And those comets are colliding and kicking dust around the dead star, which is still, well, we could see, if you could see up close, at the center of the red eye. Now, one of the reasons I picked the Helix Nebula is that this is a possible future for our sun in about 5 billion years. Not that I will be around to talk about it, but hey. Next one, the Andromeda Galaxy, M31, our neighbor galaxy, only 2.5 million light years away. For a galaxy, that's not bad. You have two pictures, actually you have three pictures, but the one at the bottom here is what we normally, well, what I see most often in the visible. Nice Andromeda. And so what you have at top is in the infrared at 24 microns, and then you have even longer wavelength at the bottom right. So what has that done, and I'll come back to this, is it's helped the scientists to study the spirals or lack thereof in Andromeda. And so in this IR picture, the top one, the red waves are the dust over what they nicely said, the blue sea of star. I hardly see the blue stars on that picture, but they were there. So Spitzer has helped estimating how many, well, what is an M31, and they said they could be up to 1 trillion stars in M31, where the Milky Way has about 100 million. Now, the important thing here is that you can see the center. If you look at the bottom, in the center with the bulge, with the light, you don't see any details, whereas here you can see the center in infrared. And then you can see all the star-forming material all the way down to the center. Now, like I was pointing out, it is not that spiral as we say. And if you actually stretch the top image, you can really see that this is almost forming a circle. So there's no spiral arms on the outside as much anymore. And so what they said, they attributed that to the fact that M32 has collided or went through M31 at some point, and has basically disrupt the spiral of the galaxy. And they made some computer simulation to see that. And in the computer simulation, the results that would have been for M31 is pretty much exactly the same as what we see in the infrared. And again, that is something that will happen to our galaxy eventually, because we're supposed to collide with M31. Not that I will be there again to see it, but if it happens, our spiral arms and their spiral arms will be totally mixed up. Now, the North America Nebula, NGC 7000, right, Paul? Thank you. Is an emission. I like Paul. He can always correct me if I'm wrong. So the emission nebula in the constellation of Cygnus, not too far from Deneb, is about 1,800 to 2,200 light years away. Somehow, depending on what I read, I got different numbers. Hopefully, eventually they'll agree. But let's say it's about 2,000 light years away, and its size is about 100 light years. The top left is what you may have seen, that I had seen, is in the visible. You can see very well that it does look like the North American continent. We're about like right there in the North American continent. There's wonderful Florida, and then you got the Gulf of Mexico and so on. And then you have the Pelican that will be to the right. And I'm using my left hand, which is very shaky, but you can see the back of the Pelican. So, so with Spitzer, they did plenty of pictures, and they're still looking at those pictures. And the top right is in a combination of infrared and visible. They wanted to see that the hot gas in the visible turning blue, which is where the continent would be, and then next to it you see the red, which is the dust and the other stuff. And then they went on and did, using two different of the instrument on Spitzer, and did two infrared pictures, and in both of them the shorter wavelength are towards the blue and then green, and then the longer wavelength are towards the red. This one stops at 8 micron, but this one goes to 24 micron. And what they have been looking into these pictures are the stellar nurseries in this nebula. And you can see them better in the IR, and I did not mention that yet, but because the young stars, they grow in blankets of dust, and with the infrared, you can see through that dust, but you cannot in the visible light. So those stars, they start to glow reddish, and you can see them with on the infrared wavelength, and you can even see some of the green shoots out of the forming stars and whatnot. You can see that there. You need to have you need to go and check out these pictures, and it's actually high resolution, and even then you have to have a bit of imagination. But I guess there down at NASA they do see that, and they're studying this. And so the team was able, looking at these two bottom pictures, to go from the known 200 stars that they had identified in that nebula to now about 2,000 new young stars that are forming in the North America Nebula. So quite a leap in knowledge here, and they published that last month, and they excuse me, and they, among other things, they were giving the example that right in this region, in just this little bit, you have a close-up and you can see all the new little stars showing up quite nicely. Now they're still doing some more research in there because supposedly they don't know what is the massive stars that would be the power source of this nebula. I found that hard to believe, but it is thought to be around the area of the Gulf of Mexico, so that would be here. So it translates to about here in this picture, And what I liked about the IR picture is whether you look at it in the red or in the greenish one, in those infrared wavelength, you can see the illumination. It's somewhere in there, and you can see it illuminates this way and this way, but you don't see what is illuminating it. So that is it for that. Thank you. So do you want me to go back or come back later? Later. Okay. Get rid of me.
Well, thanks, Sylvie. You know, one thing I wanted to say, it really struck me in preparation for the meeting here, working with Chris, was it's a lot of work to put together these slides here. And what you saw from Sylvia is one example of the amount of work that's required. I'm sure Sylvia put a lot of time and effort into you know, researching and you know, collecting your thoughts for everyone to enjoy here. So thanks, Sylvia. I really appreciate that.
That's what I did.
What's that?
She took away the presenter.
Clicker again.
All right.
Alzheimer.
Clicker.
I'm a clicker stiller.
Okay, next up is John Thompson sharing his experiences to solar eclipse, solar eclipse at Easter Island. John? It's right on the
Yeah, thanks, Mike.
Do you want to advance the slides?
Okay, there's the, and the right advances?
Yeah.
Yeah, okay. Now, I was fortunate enough, last July 11th was an eclipse on Easter Island. It actually went through the South Pacific. And I think this is the first eclipse talk I've heard since Doug George gave one in 2006. He went to Libya, which is probably not the best place to be right now. But for the last few years, for 2007, 8, 9, there was 3 eclipses went through Central Asia, South Asia, Mongolia, that area. But then this one went through the South Pacific. I'd been thinking about it for about 2 years, and about a year ago I made the final commitment when I found a tour that was staying on Easter Island for 4 days so we could see some of the statues and some of the history. Because a lot of them, I just flew in for the day, saw the eclipse, and then flew out again. So where's the
right button. Yeah. Nope.
Oops, wrong. Go ahead. Okay, here we go. Just a refresher to see what eclipses are about. I think most of you know about this, but comparing lunar eclipses and solar eclipses, both of them happen when the orbit of the moon lines up with the orbital path of the Earth, so that they fall into the shadow. Now, these are grossly out of scale. Like, the sun is actually 100 times bigger than the Earth. The relative sizes here are about right, but the moon here is actually placed, you know, way out here if it was to scale, which is why we don't get a lunar eclipse or a solar eclipse on every orbit. In fact, it's about every 18 months that they line up enough to get an eclipse. Also, for lunar eclipses, you can see anybody on the moonward side of the Earth is able to see the eclipse, whereas for solar eclipses, there's just a little point, a little path where that shadow hits. So for solar eclipses, generally you have to travel. So the next slide, oops, I'm heading the wrong way. Maybe you better do it, Chris. Now, these are the total eclipses, total solar eclipses for the 25 years from 2001 to 2025. We've marked the one that I went to. There's actually several of them there, but Easter Island is off the coast of South America. It's right in about here, more or less where those two paths intersect. Now, Easter Island is one of the most isolated places on Earth. It was a 5-hour flight from Santiago on the west coast of South America to get to Easter Island. We left around 10:30 at night, landed around 3:30 in the morning, and it was raining on Easter Island when we landed there. And here's the other eclipses that I mentioned. The last few years have been in Central Asia. Now, here's Easter Island. It's about, the dimensions are roughly 9 miles north to south and about 14 miles wide. It's triangular because it's a volcanic island. There are volcano, okay, here. Volcano, and a caldera, which is a collapsed volcano. There's only one settlement, this town of Hangaroa. Airstrip here, which is long enough to land the space shuttle if it had to do an emergency deorbit. It's about 9,500 feet long. And most of the island is not populated. Most of the population is right about here. Where we stayed was right about there. And you see on the key, these little marks all around the circumference of the island indicate the various kinds of ruins. Now there's four kinds if you look at the key. There are what they call moai, which are individual statues. There are ahu, which are a ceremonial platform that contains one or more statues. There are petroglyphs, and I think we only saw one or two of those. And then there are ruins, which I'll get to later. Okay, here's a hotel where we stayed, the Vai Moana, and we were there for 4 days. This was my roommate. It was Professor Marek Demianski, who was a visiting professor of cosmology from Warsaw, Poland. Most of this tour, I was surprised. I didn't know the group I was getting with, but half the people in this group were professional astronomers. Some of them were on sort of busman's holidays, and a lot of them were actually doing actual scientific work. And then the rest of the group were mostly adventure travelers, so there were very few actual hobbyists like myself. And there was only one other Canadian that I was aware of, which was Dan Falk, the science writer who spoke here about a couple of years ago. Day one, weather looked good. And you'll notice, that's the very first statue I saw. It was about a 15-minute walk from the hotel down to the beach. Now you'll notice that there are two misconceptions that a lot of people, including myself, had before going there. First of all, most of the statues don't face the ocean. They have their back to the ocean because they're actually set up facing inland to the village that their gaze was supposed to be protecting. They were set up to memorialize a passed-on chief who supposedly had some spiritual beneficial influence after he passed on. Here's another statue. This is a very old one. You can tell by the degree of erosion. It was probably 1,000 years or so old. Most of the statues were built, we think, between 1000 AD and about 16 or 1700 AD. And the platform is that ahu. Day two, the clouds moved in early on, and this is about the time that the eclipse would be taking place on day 4. So things weren't looking great, but the weather was very changeable. 15 minutes after that, there was a big opening in the cloud and there was a lot of blue sky. Now this is the part of the island where the kind of statues, sort of these iconic images of Easter Island that you usually think of, are in this area. This Aranu Haraku is the quarry where the things are made. There's actually about 800 statues on the island. About 400 of them are incomplete in and around the quarry. They're made of a kind of volcanic rock called tuff. It's a little like pumice, except it's denser, not as porous as pumice is. And here are some of the statues that are in the process of being made that were never completed. The statue building era ended somewhere between 16 and 1700. Just to give a scale, here's some people down here. These ones are actually bigger than most of them. That over the centuries, the statues tended to get bigger and bigger, almost like the tribes are trying to outdo each other about who can make the biggest statues. This is a head that actually broke off when the body is over here somewhere, and the head broke off, so they quit making it. And here are a couple of the largest ones that never made it out of the quarry. Average size of the statues is 4.5 meters, or about 15 feet, and the average weight is about 70 tons. But these ones, if they had ever been completed, would be about 4 times that size. Now here's the slopes where these heads are. Now these ones are facing outwards, but these are incomplete statues that were set up in pits after they came out of the quarry up here in order to try to finish them off, because they were done horizontally. They'd have to chip out the back of them, which left a very rough back. Then they would be set up in a trench or a hole where they could finish off, smooth off the back. And over time, after these statues were quit making, these holes just filled in. So even though they look like heads, there's actually more body underneath there than there is a head. And these ones would have been probably 50 feet high if they'd been on a platform. And I had to get a picture like that.
Wow.
Yeah, it's a moai, they call it. Now, these ones are more typical. That's an ahu, and I think there's 13 statues there. A couple of them have these top knots. Of the 800 statues, I think 400 were actually standing, and only about 100 of them have these little red rocks that come from a different quarry on the other side of the island. It's a different kind of rock. And the interesting thing is that after about the mid-1700s, almost all of these statues have been knocked down due to intertribal warfare. Well, actually, there's two theories: intertribal warfare, or else the people got disillusioned with their gods and knocked them down themselves. So by about mid-1800s, all these statues were knocked over face down, and it wasn't until about the 1950s that the archaeologists started putting them back up again on their platforms. So most of them, that's what they referred to as ruins. They left a few of them knocked over. I don't have a picture of one here, but, and here's another one of these Ahu with the statues. Here's day 3. It poured rain the entire day. I was supposed to be on a horseback ride going up to one of the volcanoes, but they canceled that because of the rain. So a lot of us went to the Archaeological Museum not too far from the town of Hangaroa. And we did go on another tour of a different part of the island to see more statues, but all the pictures from that day, almost all of them have water drops on my lens because it was just pouring rain the entire day. It didn't look good at this point. That night, a typhoon came in, a strong tropical storm. I should have mentioned that the predictions before going to Easter Island was about 55% cloud cover. So we knew it was a gamble, that odds were less than even that the sky would be clear, or if we're lucky, we might get to see the eclipse in holes in the sky. It's interesting, the Tahiti end of it, the western end, had slightly better predictions, but they were clouded out altogether. So here's eclipse day. This is about 10 in the morning. The typhoon had finished, and the sky was clearing, but you can still see there's a lot of clouds along here, and the clouds are sort of moving from back sort of forward this way. This is the beach at Tahai, which is where a lot of people went. Might say that the population of the island is around 4,500, but it doubled pretty much for eclipse day. And a lot of them, the day before and the morning of the eclipse, there was something like 4 or 5 jumbo jets landing, and a lot of them were Japanese people coming in from Tahiti area, from Japan via Tahiti. Now, this was our hotel again, the area. This was a group of Greek scientists who were doing scientific work. They had 2 spectrographs that they were looking for 2 lines in the solar corona, one they called the red line and one they called the green line. The green line in particular they wanted to see, which is iron. They called it iron 14, but it's iron with 13 electrons stripped off, because iron 0 is neutral iron. So this iron 14 would only exist if the solar corona is 1.8 million degrees or higher, and that's what they wanted to see. This thing was my telescope. My luggage didn't get past LaGuardia Airport, so I lost my tripod, but a local carpenter made this thing for me. And you can see a smear on the lens that from the water from the previous day there. Here's a close-up of the spectrograph. This thing is a coelostat. That's a rotating mirror that takes a beam of light as the sun rotates and makes it stationary as it goes through the optics of the spectrograph. And there's an image rotator that this thing rotates so they can put the slit on various parts of the limb and the actual spectrograph. There's Professor Mariansky, my roommate. This is Professor Jay Pasikoff, who you might have heard of. If anybody has a copy of the Peterson Field Guide to the Stars and Planets, he's the author of that. And he's also the author of a popular astronomy, like first-year astronomy text for U.S. colleges. And then those are a couple of the students. This thing is a giant Nikon telephoto lens. I have no idea how much that thing would have cost, but I thought it was a telescope, but it's actually a Nikon telephoto lens. And I'm not sure if this is the one, but they also had a Teleview NP101 photovisual refractor. Not sure if that's it or not. There's Professor Pasikoff with a solar viewer. He's taking a look at the partial phases. At this point, I had a choice of either staying at the hotel, and I was invited if I could have helped out with some of the scientific work, but it turned out that scientific work involved just removing filters or putting them back in at the right time. Anyway, I walked down to the beach to see what it was like, and it was actually a little better at the beach, I thought, so I stayed at the beach rather than at the hotel. This is 30 minutes, and you can see we're still dodging clouds. That 55% cloud cover looks pretty accurate. That does look like about 55%. I set up originally at this thing, which I thought, well, it turned out it's not a relic. It's not an one of the like the statues or anything. It turned out what it is, it's a memorial to an archaeologist. So the Chilean authorities wouldn't let me sit there. I wanted to brace my elbows on my knees, but anyways, I had to move on. I was wearing my eclipse glasses, and the person who took that picture then suggested this pose, which was even better. I wouldn't have thought of that, but anyways, my back is, the sun is to my back, which is why they couldn't really see the face. But that's the site. And this beach was probably maybe a couple of 1,000 feet long. And the greater part of the people were, were down, way down towards the museum. Probably several thousand people down there. There was maybe 1,000 people down at this part where I was. 20 minutes to go, it's looking good. You can see it's getting darker. 15 minutes, some clouds move in front of the sun. I got out my eclipse glasses and just shot through my camera. I just put the eclipse glasses in front of the lens. You can see the crescent as the sun's disappearing. It takes about 90 minutes from first contact, when the first silhouette of the moon touches the sun, to totality. Here's 5 minutes, and most of the clouds have cleared. And then here's totality. Now, totality was about 4 minutes and 50 seconds, which is fairly long, but this is the third eclipse I've been to, and I've learned not to try to spend too much time taking pictures. I did take 3 pictures and a video, but most of the time I spent just taking in the entire scene, absorbing all of the various environmental effects and all the changes that are going on in the sky, the temperature drops. Forgot to look for shadow bands, though. But, it's funny, nobody even mentioned that, to look for them. So I took 3 pictures that I tried to bracket the exposure. That was about a 1/16 of a second, an 1/8 of a second, and we're getting towards the end of the eclipse here. And that was about a 1/4 of a second. And at this point, the eclipse is nearing its end, and you can actually see out here is the part of the sky where it's no longer in the eclipse shadow. The shadow ends right about here. So this part, we're still under the eclipse, but out here, off in the distance, you can see where the eclipse has ended. So I did manage to get one video here, and I guess this is it. Run that, Chris. Okay, here we go. About a minute left. Illumination is dropping quickly. We'll have Bailey beats in maybe 20 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. Not yet. It was dropping. Here we go. Here we go. So the camera's always fading, but still too bright without the filter. Almost. And there it is. Bailey's beads. Diamond ring. We're going dark. Amazing. Look at that. Oh, wow. Perfect. Beautiful. There's Venus. Yeah, people get excited. Oh, so beautiful. What a sight. Perfect sky. And I intended to take a video at the other end of the eclipse of the sun coming out, but I just got so caught up in the experience that I neglected to do that anyway. And we have another one? No, I didn't.
Long past it.
Another
it was
video.
10 slides back.
Oh, okay. I didn't. Anyway, there was one that I took from YouTube, which I thought was here, that showed the entire 5 minutes or so of eclipse speeded up by a factor of 10, so you can actually see the shadow of the moon going across the sky. You can see it, the shadow approaching, then it gets dark, and then you can see the shadow as it recedes again, as it gets light up here. So there's a telephoto lens image. These next few were taken by somebody that I met at the airport when we were sharing pictures. So he had a nice setup there. You can see the two planets. I did notice Venus. I wasn't aware of Mercury coming out, but it was fairly faint. And again, that's near the end of the eclipse because you can see how the daylight is appearing. And there's sort of the edge of the Earth's shadow, or the moon's shadow. There's totality. One of the things that Professor Paskov was doing, they were monitoring the magnetic field reports from the solar observatories in California and New Mexico, and they had software that could predict, or they tried to predict, what the corona was going to look at like. And it came out actually quite good. Their predictions came out very good compared to, based on the magnetic field. There's third contact, diamond ring. Totality is ended, now partial phase. And eclipse is over. So we had another afternoon and evening there at the island before we took off. So I stuck around there for another 10 minutes or so and then joined the group back at the hotel. Final image, this is one of the jumbo jets, I think, probably heading back to Tahiti. We stayed, we didn't leave until later on. Actually, it was around 6 in the morning the next day. And this is actually the only sunset we saw because of the bad weather, because of the clouds moving in. We didn't really know how to expect the weather, but fortunately we did get this one nice sunset. So it was quite a experience. It was my third eclipse, like I mentioned, and it was a group called a Classic Tours, and this Professor Pasikov is involved in all of them. And I think he said it was his 50th eclipse, but then he goes to partial eclipses and annular eclipses as well as a total one. So Mike, do you want to? Sure. And I do have some, I brought some more resources, maps and things, information about Easter Island if anybody wants to talk about it afterwards. But I'll give it back to Mike.
All right. Thank you, John. You may remember the slide that John showed right at the beginning there. You'll notice crossing North America are two eclipse paths, solar eclipse paths, one in 2017 and one in 2024. So if we go ahead, you get another view of it. You can see the one in 2017 is a little bit, obviously a bit to the south of us, but the one in the 2024 actually makes its way up towards us quite nicely. So we're at 2011, it's coming up pretty quickly here. The one in 2017, the maximum duration of it will be 2 minutes 40 seconds, and the one in 2024, it looks like it's coming real close to us, the path. Now the maximum duration at the greatest eclipse is 4 minutes and 28 seconds. I don't know what it will be as it gets closer to us, but well, it's what 13 years from now. So hopefully we're all around here to see it. So it'll be nice to see something like that. But as John mentioned, seems like there was quite a few of them in Asia, but these two are in our neck of the woods, that's for sure.
Particularly cloudy in Ottawa.
Yeah. Throw them out. Thank you, John. That's very good. Thanks for that.
On a serious side, when you think it's going to be cloudy here, if you go back to 2017, that's not many years from now. It'd be really obvious for Ottawa to get together and get a bus. And it's not far to drive down to maximum duration and good skies. Who's game for it?
Okay, Pierre, you're next up for the Geminids adventure. I'll leave it there.
Well, thank you, Mike. Okay, so this is also going to be a bit of an observing report more than a talk. So for those of you who don't know me, my big passion in astronomy is meteor observing. So I'll try and cover as many of the minor and major showers throughout the entire year. And I certainly try to pay particular attention to the more major showers, which are obviously spectacular. And out of all the annual showers, my favorite, which has always been the case, is the Geminids. It's so, in my opinion, the Geminids is the most reliable shower of the year. They produce high rates and usually bright and produce nice low meteors across the sky. So they are, in my opinion, worth making a big effort to see. So this past December, I really didn't want to miss it because the gymnasts may be reliable, but they're not always as easy to see from year to year. They can vary for the reason of depending on the exact peak time, or depending on when the moon phase occurs during the month. So this can significantly reduce the number of meteors. This past December was actually a good year for the Geminids for the fact that the peak time was predicted to occur during our nighttime hours. And the moon at first quarter set just around midnight or a bit after, which made it ideal to see the best of the shower after midnight for still a good several hours right up until dawn. So unfortunately, yes, Ottawa was completely cloudy and crappy. So there was this, you may recall, mid-December, there was this storm that was coming by really large low pressure. And it brought a lot of nasty conditions, freezing rain and snow in a lot of areas. So when I noticed this, and I was still hoping to observe locally, but when I noticed what was coming, a friend and I, Raymond Dubois, and I decided to say, hey, you know what, I think we're going to have to head south. So it ends up that we decided to travel 1,800 kilometers to get away from the weather. That was how far we needed to go to make sure that we had a clear sky, that we were in an area that was not going to be 50-50, but is going to have a better shot of having solid, clear skies.
Could have gone north.
Perhaps, but we were hoping to get some warmer weather too to make it easier on our equipment. Interestingly enough, the further south we went, the colder it actually got. And it just happened to be because we were moving away from that low pressure. We were getting into the cold front, and it was a very strong front that was pushing a lot of air through. And it was not only colder as we went south, but it was also a lot windier. And as a result, the last couple of hours drive down, we could really feel the wind shaking the car. And the wind did not let up for pretty much our entire stay over. So we made contact with a really friendly group down there who managed what's called the Deer Lake Astronomy Village. It's a bit similar to the more popular Chiefland Village in Florida that you probably know, but we found out about this one, and it's a gorgeous area. It's very, very well maintained, short grass. It's like Chiefland, it's designed to be an astronomy village and like a resort under really dark skies. A blue light pollution zone, which is one of the darker areas in Georgia. It has a separate field that's designed for large star parties or just general observing, as well as another area that's a bit like the village portion has cabins and people who built their observatories and even their houses and actually go there to do all of their imaging or observing. So the Americans were very, very receptive when they learned that we were coming down. They got all excited and they said, hey, you know what, we'll open up the place for you. We'll make it nice and comfortable, and don't worry about having to pay. If you want to drop a few dollars in the box, go ahead. But as it turns out, as we got there, sure enough, the gate was all wide open. Nobody was there, but they made sure to open it up, unlock the door to the warm room, as well as the showers and the flush toilets, and everything was all set up for us. It was really, really comfortable, and not only comfortable but luxurious too. They have Wi-Fi internet connection. There's an entire row of posts along the field. Each post has power. Has AC power.
Each second post.
Each second post, actually, yes, thank you. And there's all kinds of comfortable aspects to it. Microwave, fridge. There's power for RVs. The showers are available, so they really made it as comfortable as possible for us. It was really great to set up. So Raymond and I said, we don't see it on the picture because those shots were actually taken, I suppose, while they were still building some areas of the site. But they now have 2 large concrete platforms to set up equipment, so it's a nice level surface. So Raymond and I set up our telescope, our camera equipment and our tripods on those surfaces, and we were all set. It was actually quite cold. It was right below freezing, and with the wind chill factor was several degrees. It felt several degrees colder than that as well. So come nighttime for the peak, I started shooting at around 7 o'clock in the evening, and eventually took a break for some supper. For the first couple of hours, I shot this series of image with my Canon 7D and a 15 millimeter fisheye lens, and I shot towards the north. So what you see here's a Polaris and Ursa Minor. So it was taken with my fisheye lens, and it's actually cropped, so the full image is actually quite a bit larger than that. There's more sky area on the original frame. And through the couple of hours that followed, even though the radiant was low, almost at the horizon, there was 3 nice bright meteors that scooted around Ursa Minor. So when I came back an hour later, I switched my equipment around and decided to have my 2 cameras, my 30D and my Rebel 300D and my 7D pointed in 2 different areas of the sky. And what I did is my goal was to set the 2 cameras to automatically take a series of short exposures throughout the entire night, right up until morning, always following that same field of view throughout the sky. So my goal was to accumulate as many meteors as I could, tracking onto that area of the sky from one horizon to the other, and eventually take all of the frames with meteors, and then with Photoshop combine them together and create the composites. So while all of this was happening, I was set up comfortably in my lawn chair, and then Raymond, he came out and joined me, and we both enjoyed the shower, which required nothing more than just bundling up in our sleeping bags and all our winter gear. So believe it or not, in Georgia it was really, really cold for that time of the year. Nothing that we could not handle with our equipment, our parkas and our big sleeping bags, but it's still made it interesting, especially with the wind factor, especially that far down south. It was a bit of a surprise, but the sky was absolutely gorgeous. With this shot, the moon is still up. It was a quarter moon set at about 1 o'clock in the morning, which was about an hour later in Georgia than the set time for Ottawa. And the sky transparency was absolutely spectacular. Even prior to moonset, there was a lot of meteors flying, some nice bright ones, and the sky was just gorgeous. So here's my composite image. I was done with the Canon Rebel and the 24 millimeter lens. I had this aimed towards Orion and Taurus, which you see the famous Pleiades star cluster on the right side. So this is the result of all the Geminis that flashed through between the hours of 10 o'clock and about 4 o'clock in the morning, or probably a little bit later actually, because it totaled about 8 hours of exposure time. So the individual exposures, the way that it was done was a series of 1-minute exposures throughout the entire night, always on that same field of view. And at one point, when I noticed that Orion and Taurus was nice and high, crossing the meridian, then I stopped my short exposure settings, and I took one single long exposure with the lens aperture switched down to about f4, and the ISO brought down from ISO 1600 to about 400 or so to get a better noise performance. And also sharper stars. So by choking down the aperture on the lens, I cut down on a lot of the chromatic aberration and the star flares on the corners, or the seagull effects that you can get when your lens is very wide open. So once I was done with my deep exposure, which was the basis of the background stars that you see, then I switched back to a high ISO setting, such as 1600, and I cranked up the aperture on the lens to about f2.0, which allowed me to get the maximum sensitivity to capture the fainter meteors. Because really the meteors move across the sky in a fraction of a second, or maybe at best a second or two, even in the case of the Geminis, which are relatively slow moving compared to other showers. So you can imagine that in the case of meteors, they move really quickly. They can be difficult to capture on a camera, and only the brighter ones. So I estimate that the fainter meteors that you see on the shot are probably roughly magnitude 2.0 or so, which is still fairly bright when we consider that the human eye can see meteors up to maybe magnitude 5 under dark skies.
Yeah, that really is a spectacular photo.
Oh, thank you very much. Thank you. So while this was happening with this Canon 300D, my 70, which is the one equipped with the fisheye lens, was running, and managed to capture quite a few more meteors because it's got a much larger field of view. Now what I did is I rotated the image 90 degrees so I could fit it onto the frame and give you better visibility of some of the very short meteors near the radiant. So just to quickly orient yourself, the horizon is actually on this side, just off of the frame. Orion is on its side here. Okay, there's the belt and M42. The bright star Sirius is right here. Gemini, K-Star Pollux, the two bright stars near the radiant. Hyades is down here. And M45 would be just off the bottom here, which we don't see. So as you can see, we were under gorgeous dark skies, which really made it easier to capture some good shots. Even under those dark conditions, what Raymond and I noticed is that these digital cameras are still very sensitive enough to capture distant light glows. And I had to deal with doing quite a bit of processing on my background sky, because near the horizon there was a fair amount of orange glow, caused by, I believe, was the light dome from Atlanta, which, if I'm not mistaken, is approximately 150 kilometers from where we were, like really far out. But it's it's a massive city, and the cameras will pick up that glow very easily. Now, you might be able to see them, but there's quite a few very short meteors. Almost looks like stars, very tiny streaks near the radiant, and those are the meteors that are really seen coming almost directly towards you, while the ones seen further away are longer streaks that are moving aside from us, so we really get the sense of the perspective effect. And if I'm not mistaken, on this shot there was well over 100 individual frames with meteors on them. There was a lot of work to combine them all in Photoshop, and I found that the best method to avoid reducing the visibility of the meteors and still keep the contrast was to basically do all the stacking manually in Photoshop, combine all my layers, and then simply mask the areas around the meteors out so that the meteor is left in its actual or its precise location on the starry background, which I did, as I described earlier, by taking a longer single exposure in that portion of the sky. And the next morning, by the way, I ended up visually seeing about 200 or so, actually a little closer to 300 meteors throughout my session. And it wasn't a full night of observing. I was eager to be up all the way up till dawn. And the moonset was at 1 o'clock in the morning. And I only managed to observe until 2 o'clock before I felt a little bit ill, and I decided to call it quits earlier than expected. However, the cameras just went on beautifully right up until dawn, and Raymond was helping me out for making sure everything was running smoothly and switching things off in the morning. So that worked out beautifully. So there's our setup the next day, with Raymond's setup right here and mine in the other corner of the platform. And as you can see, beautiful horizons and just a gorgeous observing site. So if ever you're taking a trip down south and you're looking for a place to stay to do astronomy, and I can definitely recommend the Deer Lake Astronomy Village. It's I cannot give it enough good marks. I think you would enjoy it. So this is it. Thank you.
Okay, for the observer reports, will the observers please step forward here and maybe form a line? Okay, so the first one here, and again, if the observers would just mind coming up here so we can save a bit of time. First one is, we go to the next slide. So this was submitted by John Thompson here. Obviously, this Aislinn is this cartoonist with the Montreal Gazette there, and if you look closely here, you can see the Walmart in the bottom there, so Northern Lights. So make what you want of this one here. Hardly observer report, but it's pretty funny nonetheless. Okay. Paul, over to you.
This is NGC 40. Now, this is not a very good picture, but the reason I'm showing this is that in most things that you see these pictures of in various books and things, it's just a white blob. It's very hard to get that center star in there. That star is 11.5 magnitude. The actual nebula is 10.7. But somebody called those two sides, they called it the ice caps on Mars. Well, I guess they look a little like them anyway. But this particular nebula is in Cephus, and it's reasonably at 10.7. Anybody can see it. It's up at 72 degrees, so you can see it the year round. It's circumpolar, so there's no difficulty. Its center star is 11.5. So you can take a picture of it or see it almost any time of the year. Being 10.7, you could easily see it in a pair of binoculars. Next, please. Now, this is an old thing, this 2099 M37. This time of the year, it's very good for observation. It's a nice open cluster in Auriga, and I think it's one of the bright ones there. There's 35, well, actually 35 is in Gemini. There's 35, 36, and 37, and 38. They're very nice this time of the year. Also visible in binoculars, and it has about 150 stars. It's 23 minutes approximately in size. Magnitude 5.6. Thanks very much, then.
Thank you, Paul. Next up is Brian McCullough. Brian?
It's the moon.
Thank you, Brian.
It's Luna.
Where is that loony guy?
Three moons. What planet is this?
Yes. Solar on way, well, it's just I've just plucked one out from the side, and I took the other shot there and set it, as you can see from the subsequent shot. It's the moon. Press on. Oh, look, it's the moon. now, this one is kind of interesting because there's a neighbor on the street behind us puts food out for ducks. So every morning these ducks fly in. So I thought, well, wait a minute. So I grabbed my camera, which is it's a new something or other that I got. And,
is that a technical term?
I think it's a Nikon. And so I banged off a couple. So you can just go through them there. I call these moon and ducks.
That's pretty cool, actually.
It's a misnomer.
He's flying to the moon.
Thank you.
Thank you, Brian. Okay, Eric. Eric LeMay.
Hey, good evening. So last summer I purchased one of the Celestron Edge HD series telescopes. Started with the idea that I'd eventually get a hyperstar lens for this, which essentially you put the camera in the front of the telescope and you get a much wider field of view. The native focal length is hold on a second here, sorry. Oh, that's not me actually, sorry. So essentially, the native focal length of my tube is 2,800 millimeters, but with Hyperstar, I take that down to about 560, and it's you shoot at f2, so it's really fast. This picture I took with a Rebel XT, I took 10 30-second frames at ISO 400 and stacked them together. The pixel size of the camera is about 6.5 microns. So I'm probably undersampling just a tad here. But so in the future, I'm going to want to try different cameras with maybe smaller pixels to see what I can do with extra detail that I can get out of it. Next, please. So here's the Pleiades, and this one right here is again at ISO 400, 18 30-second exposures, and then stacked. And the one thing that I found with Hyperstar is that because it's so fast, there really is a need to take flats. Whereas at F10, I could get away with sometimes not taking flats, but I had to process these images quite a bit to get rid of any gradient, and because of that, a lot of noise was introduced into these images. So I mean, at just under 10 minutes, I figured that if I were to expose this one for, say, an hour or so, I could bring out just a bit extra detail. This one actually, and the previous one, I took with an unmodded camera. Next, please. So here's the Rosette Nebula. This one I took, I didn't have much time because it was going down down to the horizon pretty quickly, but I managed 5 exposures, 30 seconds long. I used Robert Alexander's Beta modded Rebel XT for this one, so I was able to get quite a lot of the hydrogen alpha for this. One thing that I forgot to do when processing is to flip it horizontally. When I shoot through the scope at f10, the image is correct, but with Hyperstar it flips it horizontally, and I forgot to do that for this one. Although it seems to look okay, and I actually it took me a while to actually figure that out. Next, please. So here's the Orion Sword region. This one I took 20 30-second exposures to get the faint nebulosity, and then inspired by what Sanjeev had shown us and that image that he got published on the cover of the magazine, I figured I'd also shoot a few shorter exposures. So I got 20 10-second long exposures for the core region, and then used Photoshop to be able to do some combining and have it not completely blow out in the core. This one right here was taken with the Rebel XT at ISO 400, and it was not a modded camera. That's it. Oh, actually, sorry, I'm not done. Seems to be a recurring pattern, eh? Oh, if you notice too, I copyrighted these images this time on time instead of 7 months in advance. Had to throw that in there. Okay, so next. So inspired by the observatory that was shown last month, I figured, we have all this snow, why not make a fort? So yeah, so I went out in the backyard and I took a cardboard box for most of it and just built up the snow, and we had a bunch of sticky snow. It doesn't look all that tall in this picture, but it's about it's just a bit taller than I am, and you can't see it because it's daytime in this picture, but there's a really nasty light in the park, and then there's a light off to each side. The neighbors seem to worry about security, and so they keep a big bright light on all the time. So this right here, it reduces the light pollution essentially from the side, and the wind as well too. Of course, as soon as I built this, we got 10-degree weather the next day, and it was half the height, of course. So I've used it once since. It's just a look from inside to. I got my foot in the way, but I guess it gives a bit of scale. The very top of it, I started actually putting blocks together because I got some really sticky snow, so I was able to kind of build it directly up instead of having to carve it out from the side. And then this is just another shot from the side to give a bit more perspective. But I don't know, a couple hours. Sorry?
Looks like Easter Island.
Yeah. A couple hours of fun, bit of exercise.
Putting a dome on it?
Yeah. Well, Rob Alexander kind of coined this one, the igloo observatory.
Igloo observatory.
Yeah. But yeah, it'd be kind of neat with a dome on top. I don't know how practical it would be when it got to be a bit warmer and you had your telescope out.
Where's the war room in,
The warm room.
That's the cold room.
Yeah, the cold room. It's the gazebo, I guess. Yeah, thanks.
Thank you, Eric. Obviously, that's patent pending, right, Eric? Patent pending, right? Okay, next up,
Wayne.
John Wayne Ross.
I heard someone say, "Where's this taken?"
Space.
I have in here. I think I still have it in here. The closest picture of the moon I think anyone's got so far. I just got back. My work sends me on some pretty fun places I get to go to, and while I wasn't at Cape Canaveral, I was just nearby, so I popped over and went to the Kennedy Space Center. I was supposed to be there for the launch of the shuttle, but unfortunately, I got there the week that they discovered more cracks, and so the launch was delayed, and I didn't get to see it. Though I did get to see it with my 3-year-old daughter on channel 254. Where you can see all the NASA channel here, so that was quite exciting. This is one of the Gemini capsules, the replica Gemini capsules atop a Titan rocket. And really kind of neat, that moon is in the almost exact phase that the moon was in when the Apollo 11 EVA began. And I only found this out after the fact because I was just playing around, just wanted to see, because there's the gantry that the Apollo 11 astronauts used to board their spacecraft is just off to the side from there, and people can walk on it and so on and so forth. And I have a couple of shots through the structure of it to the moon. I just want to see how close it was to it. Anyway, just a fun picture. Which button do I push?
Oh, I can go next to you.
Ah, thank you. So they built, I don't know if anyone here has been to the Kennedy Space Center. There's recently been a new room, like a vault that's been built at the Visitor Center out at the Apollo Center. And this is the Apollo 14 capsule. I don't remember, it was Alan Shepard and Rusa and Edgar Mitchell. And they had the first Lunar Olympics where the golf ball was fired off on the moon a couple of times. And a lot of folks aren't aware, but Mitchell decided to get in on the act and coined the first Lunar Olympics and took one of their lunar sample scoops and turned it into a javelin and threw it. And these things are sitting at the bottom of a crater on the moon right now. So anyway, this is the actual capsule, the Kitty Hawk, that they came back on. Next slide, please. Now, this is the closest picture I've ever got of the moon. This is from about 3 feet away. And is Chuck O'Dale here?
No, he's gone.
Oh.
He was.
I was so psyched because when I saw this, they actually have a couple of the samples, and they're encased in God knows what, like plexiglass, and it's a bit blurry because of the lights. But I went and I researched this lunar sample, and if you go on the NASA website for each of the Apollo missions, they have catalogs of every single thing down to the minute that was done. But they also have all the lunar sample catalogs. So just as a little thing, this sample is actually part of a much larger sample that was broken off. And it comes from about 43 meters away from the lunar module. So they get out, and they have 5 sampling areas, and they went out and took some samples. And this one here, I won't even go into the details. I was hoping he'd be here because I could read him all this. This is basalt, and there's a 12-page scientific article written on this rock, which is kind of cool. About 3 billion years ago, 3.5 billion years old, 3.7. Just a fun picture. Next one, please. So the shuttle was right up fairly close to the shuttle in the area that was taking the picture from here when the Apollo rockets were launched. They had set up, it's a bunker. They have the camera set up, and they're all blown into the ocean. And it's about 5,000 feet from the actual shuttle at this point. And this is just before they begin breaking it again. There's, I don't know if you can see, but by the right solid rocket booster, there's 7 technicians, and they're in that black band, and they're looking at damage that had been done, cracks that had emerged, and one of them, while I was there, dropped a caliper down the side of the fuel tank, and it bounced all the way off the fuel tank, all the way down. And being, I won't cast any aspersions, didn't say anything at the time. The tech at the bottom heard the thing coming and freaked everybody out because apparently the banging coming down the side of a fuel tank of a shuttle is supposed to be not good. And those are full. And they had just pumped the hydrogen in. So the hydrogen's sitting in a tank just off to the side of this thing. It's not in the main fuel tank there. So anyway, they had to go through the whole thing again and check it to make sure there weren't holes in it. And apparently once before, years ago, Discovery, I don't think it was Discovery, sitting on the launch pad, they had like 190 woodpecker holes in it. Woodpeckers flew in, thought it was a giant tree and just descended on the thing. So this was kind of fun. And just one little, is there a laser on this?
Yes, center button.
This is just kind of fun because, whee, what did I do? Power. Center button. Thank God I follow instructions well. You see these lines here? Those are wires that go way out over here. And if something goes terribly wrong, the astronauts are supposed to run as fast as they can, get over here, and get on these pulleys, and they go flying way out to a sand pit. And there's a couple of M113 armored personnel carriers sitting there with the engines running and the doors down. No crew in them, because if you're near this thing when it goes off, if it goes off on the launch pad, it's a bad scene. They don't test it. They don't actually practice doing that because it's too dangerous for them to go down. They do everything but the actual slide down this. So that's kind of a fun little thing. Next slide, please.
Who are the people on that slide? I didn't see it.
Oh, yeah, here, show you. If you go back one. Right here, you can see right there, there's two people right here, and there's a group here. And one of my other images, they're over here. And I actually, on the ones where I have these at home, the high resolution ones, you can actually see them in quite good detail. And they move from over here to here. It looks like this is a person, but actually the scale is unbelievable when you see how big this thing is. That black band, from the top of that black band to the right there, that's the height of a person. So kind of, and there's these weird little balls. I've never seen them before. They're like balloons they have hanging over top of the solid rocket boosters. I don't know what they're for.
Rubber bands.
Rubber bands, probably party favors, all excited. Next one, please. This is just fun. There was a gentleman there who's taking pictures as well, and he took a quick photograph of me. It's the only time I've ever taken a picture of myself with anything. And it was just another little NASA quirk. There's something like, there's about 400,000 gallons of water in this thing. And if you've ever watched the launch on TV, as they're doing the countdown, a few seconds before they actually start the engines, they release this water and it comes flying down here. In a matter of seconds, all this water is emptied out and it comes flying into the bottom down here, and it's to dampen the sound. Because at about 300, I believe it's about 300 feet up off the launch pad, there's acoustic vibrations, there's reflection of the sound from the engines, and it'll destroy the spaceship. If you've seen the early video footage of NASA trying to launch rockets and they'll kind of go kaboom, 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 it was during that period that they figured this out. So they pump a lot of water in to protect it. And just one other small thing, because this is the night of vacation pictures. We've had, I think, 3 so far tonight. This little V here, you know when you see the launches, the plumes of smoke come out here? Strange little fact, Wernher von Braun, when they were over on the Canaveral side, there's a whole bunch of launch pads. And this is 39A, and the other early 30s are over on the far side. Wanted to see the launches. And when they fire these things, if the plumes come out in all directions, you can't see the spaceship because this whole area is completely covered in smoke. So he had installed in the bottom of the launch pads just a very simple wedge. Instead of having one in 2 different directions, or 4 different directions, he just has in 2. So that when he's sitting in the bunker, and the bunker's way over here, he can see the spaceships go off. So just why you can see the pictures of them. So there you go. Yeah, it's me. In case you hadn't figured that out. Thanks.
Thank you. Thanks, that was great. Very interesting. Sanjeev.
Hi. Well, February was a pretty cold month, but I did get out a couple of times, and this is one of the shots I did. It's Star Trails, and it was at FLO, and I used my DSLR with a 24mm lens, and this is a 40-minute exposure in total. You can see Polaris up there, and so it's pointing north. and it's 10-minute exposures that I used. So there's 4 of them, and I put them together in Photoshop with just 1 second intervals between the shots. So in the days of film, I guess you could just go 40 minutes, but I just let my DSLR go for 10 minutes times 4. So it's just a way to capture the motion of the skies. The other 2 shots I'm going to show you are actually from November, but I haven't shown them yet over here. So, and I've got a website. I've updated my website. That's my URL. This is the cocoon. I shot this at FLO as well. That's a Fred Losing Observatory. This one I did with my 5.5-inch refractor and QSI CCD camera, and it's you're looking at about 3/4 of a degree across here, and it's an LRGB composite. It's about 2.5 hours of exposures. And the cocoon, it's IC5146. It's believed to be a star forming region, and what's interesting about it is that it has like this sort of red nebulosity from hydrogen, but also has a lot of reflection. I don't know if you can see there's a lot of sort of bluish colors to it on the outside, and that's from believed to be from reflected starlight. And the other interesting thing about it is that it's at the end of this dark trail of dust, and this image only captures part of it because it goes on down there, and it's called Barnard 168. It's a pretty large area of dark nebulosity, and this is a very rich star field in Cygnus. So you can see that how the star field is all muted over here because of the dust. And this is also from November. I shot this at FLO as well, and it's of course the Stephan's Quintet over here, and there's NGC 7331. This is a fairly bright galaxy. It's one of those Messier misses. I guess you wonder why he didn't have this in his catalog, but it's about a Mag 9 or Mag 10 galaxy, fairly large. And what's interesting about it is that there's these 4 galaxies that are near it. Near it from our line of sight. They're often referred to as the 4 fleas. And but this is believed to be about 40 million light years away, maybe, and these are about 400 million light years away, or 10 times further away. They happen to be just along the same line of sight from our vantage point. The other interesting thing about this is that the Stephan's Quintet, it's also sometimes referred to as Hickson 92. It's one of the most accessible Hickson groups in the sense that they're fairly bright. They're Mag 12, Mag 13 galaxies. And it used to be thought that there's 5, right, in the group, but now it's understood that this one here, NGC 7320, is actually much closer to us. It's about 40 million light years away, and these other 4 are thought to be about 300 million light years away. So again, it's a bit of a coincidence that we're seeing them all sort of together like that. And this is also with my 140 millimeter refractor and with the QSI CCD camera, and the exposure here is about 3.5 hours.
Sanjeev?
Yeah.
If you go back one, you mentioned that little, was it 7320 there in the...
Yeah.
You said that's 40 million light years estimated, and the Deer Lake 7331.
Yeah.
That's also about 40?
Yeah, that's right.
Okay, so if they're at about the same distance, that gives you an indication of the difference in size.
That's...
And maybe there's a possibility that little guy could be a companion to the larger.
Yeah, and that's a very interesting juxtaposition, isn't it? Because this one looks a lot bigger, but yeah, really, this one and this one here are at about the same distance, and these guys here are at about the same distance. Well, not same, but same order of magnitude. The other interesting thing about these is that all of these, I've observed all of these galaxies visually with my Dob, a 14.5-inch Dob, and I haven't used it much in the last year or so because I've been busy imaging. But I have seen all of these under dark skies. They're very faint, and you need to use averted vision and be fully dark adapted. But they are accessible as very tiny, faint specks at the eyepiece if you have a 12-inch, 14-inch scope, and you take it to dark skies. Now I did this little banner in Photoshop, and I gave my website a new sort of look. So you're welcome to visit. There's lots more pictures there. Thanks.
Okay, thank you, Sanjeev. Okay, in the interest of time here, because I don't want to go too late over, we're going to finish off with the outreach, an outreach report. I'll give the view ahead, and we'll also talk about school outreach as well. Sylvie will talk about school outreach. Okay, next slide. Okay, so I think I might have mentioned in a previous meeting that Stephen McIntyre has established a schedule. We still need to get approval from the city, and I've been dragging my feet a bit on this here, but I'm sure the city of Ottawa will approve us to use the CARP library site. I'll post this on the web, okay, on our website, and the smaller dates on the left there are the rain dates and so forth. Okay, so you can see that it's going to be pretty much for every month of the year, starting in May all the way up to October. Okay, so more on that later. Next slide. As usual, it's in the for those who don't know, it's we have an observing site. It's at the Diefenbunker site, and actually in the parking lot of the CARP branch of the Ottawa Public Library. Very recognizable site. If you know where the CARP Fairground is, it's just further on up the road. Next slide. And we're in the, we usually go right here in this one of the 3 parking lots here, and this is the Diefenbunker here, and the CARP Library, and it doesn't show it here, but the CARP Fairgrounds will be down here a bit and so forth. Very a nice site. That's a known site, and it'll be great. Always free, open to everyone here, and we'll do radio promotions and so forth. Next slide. Okay, a couple of things here. The museum is starting a event, an Earth Hour event this year, and they've invited us to participate. They're still sort of forming some ideas in terms of what will be all involved with Earth Hour here. They have they've asked us to participate with bring our members bring telescopes and so forth. I said yes. If you are interested in volunteering for that, please let me know. I'll be sending out an email to the group here. But if you're not actually part of the email distribution list here, please let me know tonight if you are available and interested in this event. So this is Saturday, March the 26th. Obviously, the stargazing will be weather permitting. If you got some ideas in terms of, or you have some ideas in terms of what we can do as indoor events, the museum has sort of said, let us know. They seem to be fairly receptive to it. As you can see there, Bridgehead is offering free coffees. Okay, next slide. International Astronomy Day. Every year for I don't know how many years, we've been involved with the museum for Astronomy Day. It's a daytime and evening event, always very, very popular. We generally have about 10 to 15 volunteers, lots of folks, great time, and it lasts a full day. The last 2 years, they've been sunny days. It's just been terrific, and the weather's been pretty good. So keep your fingers crossed here. I think it's last year it was the end of April or whatever. This year it's further out, or I think it normally is around May, or first week of May. Again, if you're interested in volunteering for that, and I'll be mentioning this, I'll be bringing this up again in April. Okay, next slide. Okay, and here's some photos from last year, the Astronomy Day at the museum. Very popular event, lots of people. It's great for us, lots of great discussions here. Next slide. And outdoor solo observing always works very well. We're right smack outside here. As people come in and as people leave the museum, they see us, so it works out very well, and kind of gets them motivated too. And we're set up, our indoor display is set up right in the front here, so they can't miss us. Next slide. And then, of course, the evening star party, the observatory is open, and I think it's always a bit, I think last year was a bit iffy. We were actually thinking about throwing in the towel, but if I recall right, but it was okay. We got some planets, and that worked out well. Next slide. The Cube Gallery on Wellington, they approached us last year, and a couple of our members participated in an event that they organized where they mix art with, they have an interest in light pollution, and it's about a month-long event. It runs about the end of June to the month of July. But they have a opening party, which they would like to have a star party on that date as well. Now they've made a request to our members here. If anyone has any art, be it moon sketches or or if any kind of painting, like remember that Galileo painting that tripartite, or we were talking about earlier in another meeting. Bring it along. They would love to share those kind of astronomy art, and with the public. John, they're actually looking at us doing some sort of a talk again on. Remember the talk we did at the museum, I think, for astronomy a couple of years ago, on is there life in the universe or something like that? They're actually interested in us doing something like that. Quick, maybe a provocative discussion just to get people interested and so forth. But I like these guys at the Cube Gallery. They're very creative. They seem to know how to stretch a dime, that's for sure. And they're very well connected with the media, so that's real good. Next slide. Sylvie, over to you. Oh, thanks.
That's me again. This time I'm staying away from this gizmo. I'm not touching. Okay, so this is just a short report on a outreach event that we've done to high school teachers. Someone from the Ottawa Carleton District School Board approached Gary Boyle, and so he gave us this, and the three of us went and did something for them. That would be Rob, Dick, Brian McCulloch, and myself. So basically, it was a PD Day workshop on February 18th, and with a big group of science teachers, we prepared a presentation for them. Clicker? Oh, thank you. And and we had through the day 30 attendees. So this is the first part of what we did, which is Rob, who did the formal presentation on the solar system, plus a couple of slides from Brian. And then Brian went down to the floor and did a couple of his wonderful experiments, the Lunar Meteor Impact Crater Project. My name is there because I had to take over for the second session at the end of the afternoon, but I didn't quite do as a good job as Brian did in the morning. He also presented his T-Bag Galaxy experience. We explained to them how to use the planisphere and show them a bunch of resources and things like that could be useful to them. And that was quick. That was it, yes. We had a bunch of goodies for them, and we promoted the Rasc at the same time. So I haven't heard any feedback from this, but it seems that it went really well, and hopefully that we'll get to do more later. They're interested to having us in the future years for all their workshops, PD workshops. So.
They gave us a donation for our library.
Yes, and you know what? I forgot where I put it. Anyhow, yes, maybe I should mention, they were not they didn't know how many of us would show up, because I didn't know when I register us as a group. So I just registered the Rasc as one group. We showed up 3 of us, and it turned out that they gave us a gift certificate for something like $30, and Rob, Brian, and I agreed to give it to Estelle so she could buy a new book for the library. It's a gift certificate at Chapters. So we'll get a new book for the library, but I'm afraid I may not have it in my purse tonight, so it might go to next month. But thanks, Brian, for reminding. He says he has Alzheimer. I have Alzheimer. Thank you. You're welcome.
Actually, just a reminder, I forgot to mention earlier, Sylvie is our school outreach coordinator, so it's there's a lot of outreach activities that are happening, and the more sort of engaged we are in this, the more that will come. So thank you, Sylvie. It's a terrific help, and I know it's a lot of work, so well done. Okay, we're at the end of our meeting here. Estelle has her pick of the month for the Stanmont Library, which is open tonight. The Messier objects. Next slide. All right. Just a reminder, everyone, that you all know this. The rest of the museum is closed. Okay, so please stay away from that area. Usual. You can all read this. I think you probably all know it right now. Next slide. I've come to learn in preparing for this meeting as a lot of work, and I have to really truly admire Chris for his tremendous patience. Folks, there's a lot of back and forth and coordination and emails and so forth. This fellow here is a gem for our center. He does a lot. He's got endless patience. He made it real easy for me. So Chris, amazing, man. Attendance tonight, 115. Thanks, everyone. I appreciate you all coming. Next meeting is April the 1st.
No joke.
Bill will be back next month. Hope you all enjoyed it. Thanks, everyone.